My presentation. My name is Otoniel Campos. I'm a PhD research student here at Jacobs University Bremen, and today I'll present you my paper titled Machine Learning in Coverages. So coverages, as we all know, are a way to represent data over that contains some type of geographical semantic. So coverages in this respect, there are different special type of data called array data, which, as you can refer from the name, it involves arrays. Okay, we try to represent data in an array form. So typically, when we want to deal with array data or with any type of data, the first thing that we would like to do is to store and retrieve these data efficiently. Unfortunately, in the case of array data, normal relational databases will not be enough. They don't provide this type of semantic or this neighborhood sense to the data. For that, you will need an array database. Array databases close a gap in the database world by supporting arrays in the form of data cubes. Rastaman, in this particular subject, is a pioneer by providing not only support to the array, to arrays, but also providing two features that are used in this paper, which are user-defined functions, and the other one being this geo-coverage support. My idea is to merge these two and use the UDFs, or the user-defined functions, to ship machine learning code into coverages. So as I mentioned before, Rastaman provides many goodies for treating coverages. And in particular, I would like to mention the WCPS, which is this web coverage processing service that enables us to retrieve data efficiently that contains some type of geographical positioning. This particular service runs in Rastaman on top of the backend of the database. So it's an addition to it, and it provides some very nice and easy way of retrieving data through using some type of querying language. So what I would like to do with these two features is to provide some type of machine learning support into WCPS UDF. So machine learning support can be done by using this layer on top of Rastaman that provides this type of service. So this service itself can retrieve the data, and the code itself of the machine learning part can be encapsulated into a UDF that we can later call using this querying language. So in this respect, we will be able to ship the code from the database using geographic semantics and provide some type of processing, in this case, machine learning processing. So machine learning algorithms can be defined as user-defined functions, and these user-defined functions can be later put into an array, into a query that the database will retrieve and process the data using this machine learning algorithm. So I have a quick example for that. I'm using WCPS query, which is very much resembles XQuery. And I define one user-defined function, linear regression, that is, inside Rastaman. And in this particular example, we can see that we can define the geographic extent of this coverage, latitude, longitude, as well as the temporal one, and retrieve the data. And once it's retrieved, then it goes through the UDF workflow from Rastaman, and it provides, in this case, the result in a CSV format. The CSV format can be later represented in using a graph or map or whatever. So this was my paper in a high glance. And of course, this is a very simple example. In my future work, I would like to cover neural networks, support vector machines, and other implementations of machine learning that can be used using these UDFs. And of course, I would like to try to perform some type of testing and benchmarking against other implementations like TensorFlow. So this was all for my part. Thank you very much. And any further questions, you can send it to the email over here. Thank you very much. Bye-bye.